Alright folks, today we're working on multiplying rational expressions. This is 7.1d. So let's just think about multiplying fractions review, because in rational expressions, or just remember, they are an expression in which you can have two different expressions, r and s, or whatever we call it, on top of each other. So we're just going to practice multiplying them. So we've got two of them like this, we're just going to smash them together, kind of like these examples we have. So multiplying fractions. Remember that we multiply fractions, so if we have fraction a over b times fraction c over d, we just multiply straight across. So we multiply a times c, which is ac, we multiply b times d, which is bd. Just multiply straight across the numerators, straight across the denominators. So if we're going to think about this with numbers, just to make sure this actually makes sense, let's think about half times a half. Well, we know that half of a half is equal to a quarter, because you take half of a half, break the half into two parts, you have 2 quarters. So 1 times 1 gives us 1, 2 times 2 gives us 4. So yes, this definitely works right here. So remember, for multiplying, we just multiply straight across. Alright, so let's deal with this with some rational expressions now. So for each of the following, we're going to A, multiply, B, determine our excluded values, and C, fully simplify. So let's look like multiplying first. So we multiply. So
that's going to give us 3 times 4 is going to give us 12. Don't forget we're multiplying here. Divided, and some x's. So x times x to the third is x to the fourth. 2 times 5 is 10. And it looks like we have just x squared in the bottom. So we've multiplied. Now we need to determine our excluded values. So our excluded values, remember, we can't divide by 0, so we just want to take that denominator and say, hey, this bottom part cannot be equal to 0. What's our excluded value? So we can divide both sides by 10. We'll get x squared cannot be equal to 0. And then the square root of both sides is going to give us x cannot be equal to 0, because 0 multiplies by itself to be 0, and 0 multiplies by 10 to be 0. So our only excluded value, our only part b, is x cannot be equal to 0. So when we say fully simplify, that really should just say simplify. You should always understand that simplifying just always means fully. So let's look at our like parts here. 12 over 10, we can divide each of these by 2. So I'm going to divide both of those by 2. I'm going to get 6 over 5. 12 tenths is the same as 6 fifths. We got the same amount of parts there. And in the last part, we have x to the fourth, which is x, divided by x squared, which is xx. We're going to cross off the same ones. We're left with just 6x squared over 5. So this expression is equivalent to this final expression. This is our final simplified version. And we have our excluded value over here. And that's all we have to do. So this is pretty straightforward if we have simple monomial times binomial. Unfortunately, down to binomials, we're going to have to do some more work. So the first thing I'm going to suggest you do here is factor. Always, always, always try to factor. So don't forget we have a difference of squares. There's subtraction. And these are both perfect squares, which says we have something squared minus something else squared. That's going to give us a plus b times a minus b. So basically, we take the square root of each of them, one's plus and one's a minus. So I'm going to factor my top part first. So x squared minus 4 turns into x plus 2, because the square root of 4 is 2, times x minus 2, all divided by x plus 1, because this is again a perfect square, 1 times 1 gives us 1, times x minus 1, all multiplied by x plus 1 over x plus 2. So remember, when we multiply, we just multiply straight across. So I'm just going to write all of them that are in the numerator on the numerator, all of them that are in the denominator on the denominator. So that's our multiplication. Second step, determine our excluded values. Remember, we can't have 0 on the bottom. So we've got 3 different things. If any one of these was equal to 0, then 0 times anything is going to give us 0. So we have to check all 3 of these. So x plus 1 cannot equal 0. X minus 1 cannot equal 0. And x plus 2 cannot equal 0. So we're going to subtract 1 from both sides in the first one, giving us that x cannot be equal to negative 1. Add 1 on both sides to the second one, which says x cannot be equal to positive 1. And subtract 2 on both sides of the last one, which says x cannot be equal to negative 2. So these are our excluded values, which is part B. Okay, and the last thing we need to simplify. So remember, we simplify, we cancel the same thing on the top and bottom, just like we did up here. But here we've got 3 different binomials in the numerator and the denominator.
we need to cancel only the ones that are exactly the same. So we have an x plus 2 term in the top and an x plus 2 term in the bottom. So these are going to cancel. We have an x plus 1 in the top and an x plus 1 in the bottom. So these are going to cancel. Unfortunately, x minus 2 and x minus 1 are not the exact same thing. So when we simplify, we're going to get x minus 2 over x minus 1. And this is the fully simplified version. So that's our part C. So to summarize, here's some things that are going to help you out. 1, if you can factor, and we couldn't factor the first top or bottom and the second top or bottom, but we could factor these guys. So if you can factor, factor. Always check for factor first. Always, always, always. It'll make things a lot easier because multiplying these and x plus 1 over x plus 2 is a lot easier than multiplying this stuff. Excuse me. Part 2, we're going to multiply, and remember when we multiply, just straight across. Straight across. So we multiply x plus 2 times x minus 2 times x plus 1, and x plus 1 times x minus 1 times x plus 2, because this factors into the top, and then x squared minus 1 factors into the bottom. Part 3, we need to find our excluded values, so we're going to determine excluded values. And some questions may not ask it. It may not
ask it. So if we don't need to, let's not. And then the last part is whenever we can, simplify. Alright folks, so I just showed you how to multiply rational expressions. Let's get some practice. Good luck.